Hi Year 10, welcome back to Breakdown Maths, second video. So you should have already done your do now, and I'm just going to go through that now so that you can find out basically how you've got on. So first of all, you should have done root 7 times root 7. So remember, when you times a square root by itself, you just get the number underneath, so that would just give me 7. Then we need to do the root 7 times by the minus 2. So root 7 times minus 2 is just minus 2 root 7. Right, now I need to do this 2 here, the positive 2 times each of these. So positive 2 times root 7 is plus 2 root 7. And then we've got 2 times minus 2, so that's going to give me minus 4 on the end. So when you simplify this now, we've got minus 2 root 7 plus 2 root 7. Well, I know that minus 2 plus 2 would just get me back to 0, so it's exactly the same with these, even though they've got the root 7s after them. So minus 2 root 7 plus 2 root 7, that would just get me back to 0. So all I've got to do is the 7 minus the 4, which is a nice easy 3. So part B, using your answer from A to rationalise this. So when we rationalise something like this, we want to times it by what is on the bottom, but we want to change that sign there in the middle. So because I've got a plus here, we want to times it by the same thing, but we're going to change it to a minus. So it would be timesing it by root 7 minus 2. And because I've done that to the bottom, I want to do the same thing to the top to keep that fraction equal. So I'm going to times the top by root 7 minus 2 as well. Now when I times both of these by the 3, you just got to be careful that we do make sure to times both of them and not just the first bit, which is what lots of people do. So we want to make sure that we do 3 times root 7, so that's going to be 3 root 7, but I also want to do 3 times the minus 2, so that's going to give me minus 6. Now the bottom bit looks really horrible, but hopefully the fact it says here that use your answer from A, hopefully you should have noticed that look, if we put this into brackets, these brackets match up to the brackets up here, and I've already expanded those, and we know already that equaled 3, so I can just make the bottom of this fraction 3. So I imagine a lot of you may have stopped there, which is okay, but we can just simplify it a little bit more. Remember, that means divide by 3. So 3 root 7 divided by 3, the 3's there are going to cancel out, so that would just give me root 7. And then 6 divided by 3, I know, is 2. So that there should be really, ideally, your final answer, so root 7 minus 2. Okay, moving on to the solving one. So this is where you should hopefully recognise that this is where you're going to put your lines down like that. And we're going to do the same thing to both sides. There's no x squared in there, so I'm not going to try and put this into brackets. It is just where we do the same thing to both sides. So first of all, I normally start with the x's. So looking at your x's, you've got 3x here, 4x here. So you want to take away the smaller number of x's to keep them positive. So I'm going to take away 3x from both sides. So that's going to get rid of them here on this side. 3x minus 3x is just nothing. So I'm just going to be left with the 9. 4x take away 3x is just 1x or x. And then I've still got that minus 3 there. So I now want to get rid of the minus 3. So to do that, I'm going to do the opposite, and I'm going to add 3. So when I add 3, it's going to make 12 here. And then again, the whole point of doing that was to get rid of that minus 3. So I just get that 12 is less than x, and that's my final answer. Right, moving on to this one up here, then we had upper or lower bounds because things have been rounded here. So before we even look at this bit, I'm going to decide what my upper and lower bounds are for each of these. So if this was 3.2 to 1 decimal place, remember we've said in class before, to find the lower bound of that, so LB for lower bound, we just make this 1 less. So 1 less than 2 is 1. So it would be 3.1, and then we just put a 5 on the end like that. So that's my lower bound. The upper bound, we can just put a 5 on the end. So it would be 3.25. Right, the next one is a little bit trickier. So the 40 is to one significant figure. So if something's been rounded to one significant figure, it would mean that it's only that first digit there that's been rounded, and everything else afterwards would have been replaced with 0. So the answers, if it's been rounded to one significant figure, could be something like 20 or 30 or 40 in this case, or 50. So your upper and lower bound are just going to be like halfway between the 30 and the 40, and then also the 40 and the 50. So my lower bound would be 35, because that's halfway between the 30 and the 40, and my upper bound therefore would be 45. Okay, so that bit there was a little bit tricky. Right, finding the minimum value of b minus a. So I want this to be as small as possible. So therefore you've got to think about your first number here. If you want this answer to be as small as possible, I really want to start on a small number. So looking at my values of b, which are these two here, I've got to decide which one do I want to start on. Well, this is the smallest, the lower bound, so therefore I'm going to start on 35. Then you want to decide, well, do you want to take away a bigger number or a smaller number? So again, if I'm trying to make this whole answer as small as possible, it's going to be smaller when I take away a bigger value here. So looking at my values of a, that's going to be my bigger one, the upper bound. So I'm going to do 35 minus 3.25. So that is going to give me an answer. You should have got 31.75. Right, the final one in the do now, and there was one a little bit like this yesterday, and a lot of you had just forgotten what to do. So first of all, we have a P over there and a P here as well. So the first thing is to get those onto the same side. So I could minus CP, but if I do that, I've still got this plus B, and it just starts getting a bit messy, so I wouldn't do that. I would probably take away the AP, because that AP is positive. So let's take that away, and that will go onto the other side now. So this side, it just leaves us with B. This side is going to be CP and then minus AP. So now we have them on the same side. So once we've done that, and it appears more than once like we've got here, your next step is to factorise it. So you'll notice we've got a P there and also there. So I can take that outside my brackets like that. And now I want P times something is CP, so that would have to be C, and then P times something there to get the AP would have to be A. And once you've got your bracket, you can then just divide by the bracket, so divide by C minus A to get your final answer. So B over C minus A equals P. Okay, and then I know quite often in class we've talked about how we can swap the sides around, so we could say that P equals B over C minus A. So I haven't really done anything with it apart from flip the sides over just to get the P on the left. Okay, so the next part of the video is now moving on to like the revision section. I think at the moment, at least up until the Easter holidays, I'm just going to pick out some topics that you should have done back probably in year 9, that you just may have forgotten, and then after Easter we'll start moving on hopefully then to some new material. So we're going to look at arcs and sectors. So just before we do, I'm just going to quickly run through the basics. It's better to start from scratch and build up from that. So obviously this is a circle. There's my centre, just to check that we are familiar with the term. So if it goes from the centre to the edge, that is called the radius. And then if it goes all the way through the centre, like that, then that is called the diameter. And just a reminder that if we know the radius, to get the diameter we can just double it. Likewise, if we know the diameter, half of that would give us the radius. So there's two really important formulae that you need to know for circles. One is for the area and the other one is for the circumference. So the area is to do with the space inside, whereas the circumference is the distance all the way around the edge of the circle. So it's basically a posh word for the perimeter of the circle. So the area, the formula for that, you probably would have seen this before, but you should have seen this before. So it's pi r squared, which means that you're doing pi, which there's a button for that on your calculator, times the radius squared. Whereas the circumference, so again, just a reminder, that's the distance around the outside, that would be pi times the diameter, or pi times d. Right, so moving on, if we have a look, we're going to have a look at these arcs and sectors here. So this here is called a sector of a circle, so it's just part of a circle basically. That is your centre there. So first of all, we're trying to find the arc length, so that would be this distance here. So you'll notice that that is part of the circumference of the circle that we were talking about up here, isn't it? It's to do with the edge of that circle. So it's to do with the circumference. And I know from up here, the formula for circumference is pi times d. So if I know that this is the centre and this is the edge, the radius of that circle must be 6. So if I know the radius is 6, I can double that to get the diameter. So I know the diameter is going to be double 6, which is 12. So going back to my circumference formula, the circumference of the whole circle would be pi times 12. Now you might be thinking, but I don't want the whole circle, and you're quite right. We don't want the whole circle, we just want this little bit here. So the final step now is to think about what fraction this is out of the whole circle, and this bit is actually not too bad. We know here this angle look is 48. If you imagine the whole circle and all the angles around here, they would add up to 360. We should know that angles around a point add up to 360. So my fraction is just going to be 48 over 360. And so I need to find that fraction of the whole circle, which again sounds really complicated, but actually I can do that by just timesing them together like that. So I would then get my calculator, I would use my fraction button, so 48 over 360 times by pi times by 12. So that should give me an answer then, and you might want to check that you can get this, of 5.03. We'll go for 2 decimal places like that. And the other thing I should point out actually is that arc length is a distance around the edge, so that would just be measured in centimetres. Right, moving on then, the perimeter is the distance around the edge of the whole shape. So we know from here to here is 6. That's nice and easy because that's labelled for us. This distance here, well, that's what we've just worked out here, isn't it? So we now know that that is 5.03. The only one that's not labelled really is this one. So this is the centre, it goes out to the edge, so this is a radius exactly the same as this one. So if this one is 6, that there is also going to be 6 as well. So to work out the perimeter, all I have to do now is just add up these 3 measurements. So it will be 6 plus 6 plus then this one here that we've just worked out is 5.03. So that's just going to be 17.03 centimetres. Okay, area, so it's going to be very, very similar. So I'm going to start straight away. It's the same sector, it's going to be the same fraction again, isn't it? So I know my fraction is 48 over 360, but this time I want the area. So I'm going to have to use my area formula up here. So it's going to be pi times the radius squared. So the radius of the circle, again from the centre to the edge, the radius is 6. So it would be pi times 6 squared. And again, I need to work out that fraction of this, and I can just do that by putting in the times like that. So again, when you put this in your calculator, 48 over 360 times by pi, but this time times by 6 squared. And so that gives me an answer of 15.08. And now this time it's area, so hopefully you would remember that actually area is centimetres squared. Right, I think at this stage some of you may now be fine to move on to the questions that I've set you. Just a reminder that you do need to email that to me as well. Some of you are doing it via Show My Homework, and that is okay, but if you don't hear it back from me within about, I would say, an hour to say that I've received it, then I would maybe either try it one more time or just go for email. Email seems to be the best approach at the moment. If you do want another example, I can do that now for you, so if you want to keep listening, then by all means do, but if you are happy, then go for it and try the questions. Right, the final example then, if you do want one more example just to check that you definitely got this, I've just realised I am missing my radius there, so I'm just going to add that on. So that should have been there at the start, I've just added that on. So first of all, the area of this sector. So I've purposely done it in a different order to last time, just to make sure that we do know what we're doing and not just copying exactly what I did up here. So area, first of all, I'm going to look at my fraction. So my angle this time is 110. So I would do 110 over 360. So it's always going to be over 360. Then again it's area, so area, if you can't remember, let's look at the formula. So area was pi times the radius squared. So I'm going to do times pi times the radius squared. So remember, here's the centre, here's the edge, that's my radius. So it's just going to be times 10 squared. So again, typing that in on my calculator. So 110 over 360 times pi times 10 squared. So that gives you an answer of 95.99 centimetres squared. Right, arc length, so again, same fraction, so it's going to be 110 over 360. But this time, remember, arc length is to do with the circumference, so going back to my circumference formula, it's pi times d. So this time I'm going to need the diameter of that circle. So remember, if that's the radius, double that to get your diameter, so 10 times 2 is 20. So it'll be times pi times 20 this time. So going back to the calculator, so it's going to be 110 over 360 times pi times 20. So you get 19, it's not a particularly nice one to round actually, we're going to go for 19.20 to 2 decimal places. And this time it is centimetres, because it's just a distance. So last one, the perimeter, so remember that is the distance all the way around the edge. So this is 10, that means that's also going to be 10, remember, because it's just a radius as well. And then we just need to add what we've just worked out here. So it would be 10 plus 10 plus 19.2. So that's going to be 20, so it's going to be 39.28 centimetres to 2 decimal places. Okay, so if you've kept watching through all of that, you can now try the questions and remember to email it to me. Good luck.